Joint hypermobility syndrome refers to joints with ranges of motion beyond the normative. Hypermobility has no cure, and symptoms are managed through pain relief medications and physical therapy involving strengthening the muscles and joints. We present FlexFix, an assistive monitoring device which provides visual feedback on finger flexion and force. It enables individuals with hypermobility to better manage the use of their fingers to minimize symptoms such as fatigue, redness, and locking of the joints. Our work was motivated by an interview we conducted with a woman in her late 60s with hypermobility and osteoarthritis. She enjoys working with her hands and doing fine manipulation activities such as restoring antique jewelry. Sometimes, Arnina reported redness at her fingertips and fatigue and pain in her finger joints as a result of overgripping during strenuous and repetitive tasks. We hypothesized that providing visual feedback correlated to finger flexion and force will enable individuals with hypermobility to modify their behavior to reduce discomfort. A finger telemetry system was designed consisting of an ankle measurement and a piezoresistive force sensor for measuring pressure. A series of ring-like structures secure a one-axis Ben Labs sensor along the dorsal side of the hand. A wrist-worn microcontroller processes the data based on a cost function and triggers a three-stage visual indicator as a predictor of the individual's future joint pain. A functional prototype was then constructed using 3D printing. The structural rings at the fingertip and distal interphalangeal joint were printed with a flexible 80A durometer material. The structural ring at the proximal interphalangeal joint and the resting mount over the metacarpal phalangeal joint were fabricated in PLA plastic. An ESP32 Arduino microcontroller and a NeoPixel LED are housed over the wrist. As the user flexes their finger or applies pressure at the fingertip, the light indicator will turn from green to yellow to caution the user. When the next higher state is reached, the light turns red and a vibration motor in the watch body activates to draw immediate attention of the user. As the user slows or reduces their finger activity, the state will change back to yellow and green. The development of the proposed device can create a data set which can help future researchers correlate and design solutions to a range of dexterous and joint-related ailments. Such a system could be introduced at early onset diagnosis in younger age patients, serving as a training tool which may help individuals prevent overusage of their fingers before reaching levels of fatigue and discomfort.